With a few relatively simple rules, we've already learned how to take the derivatives of some fairly complicated functions. What's the derivative of this function? X e to the x. Seems simple. Seems certainly more simple than the last example we saw, which was e to the sine of the square root of 3x squared plus 4x plus those complicated chain rules within chain rule problems. This is fairly simple. It's just x times e to the x. Derivative of x is 1. Derivative of e to the x is e to the x. But how do we compute the derivative of x times e to the x? That's what we're going to learn today in our lecture on the product rule. As it turns out, the derivative of this is also fairly simple to compute, even though we haven't learned the technique of how to take this derivative yet. The product rule applies whenever you have a product of two functions. So when you have y is equal to f of x times g of x. So right away it's simpler than the chain rule, because with the chain rule we had f of u of x, or call it g of x if you want. We had basically f of g of x. We had the composite of two functions. One function was inside of the other function. Here it's not so difficult because it's just the product of two functions. It's f of x times g of x. Of course, it's not all a cakewalk, because f of x and g of x may require the chain rule to compute. So f of x might have elements that would require the chain rule. Maybe f of x is sine of 5x squared, and then g of x is e to the cosine of 5x squared, or something like that. But whatever f and g are they're both functions that we can compute with the techniques that we already know. Maybe the chain rule, maybe not the chain rule. This example here, f of x would just be x. So f of x we would just call x, and then g of x we would just call e of the x. So the product rule says the following. It says that the derivative of f of x times g of x is just f of x times g prime of x, and then plus f prime of x times g of x. So basically when you have a product of two functions, a first function and a second function, the derivative is just the first times the derivative of the second, and then plus the second times the derivative of the first. That's the way I learned this. It's the first times the derivative of the second, and then plus the second times the derivative of the first. And also, don't let the formalism get in the way of a problem. Oftentimes they'll say, here's a function, take its derivative. And oftentimes that function will be f of x. So the formalism is useful in studying the rule itself. It can sometimes get in the way or conflict of an actual problem. If somebody tells you, here's f of x, and that's going to be a product of two things. For example, if someone said f of x is x e to the x, it gets confusing if then you turn around and say, well, f of x is just equal to x. But as with the chain rule, once you get the rule into your system, you don't need to actually identify f of x and g of x except for in your head. It's the first function and the second function. We have x and then e to the x. So I would apply the product rule here without necessarily saying f of x is equal to x, g of x is equal to e to the x, and rely on the formula. I rely on, I've done it a million times, so it's in my system, it's in my blood, and I can just say, okay, I'll show you how I do it. X e to the x. dy dx is the first x times the derivative of the second plus the second times the derivative of the first. That's it. analyze what I did, what was going on in my mind when I did that. So the first function is just x, so I replaced the x like that. First times the derivative of the second. Well, the second was the e to the x. The derivative of e to the x is e to the x. So it's x e to the x. Okay, great. First times the derivative of the second, then plus the second. So here's the second. Now I did not take the derivative, I just rewrote it, even though it's the same thing in this case. E to the x times the derivative of the first. Derivative of the first, derivative of x is just 1. So e to the x times 1 is just e to the x. So the derivative of x e to the x is x e to the x plus e to the x. And the formula works exactly the same. This is exactly a blueprint for what I just did. It's f times the derivative of g plus g times the derivative of f. Let's do another example. Suppose we have y is equal to, let's do this one, sine of x times cosine of x. And let's compute dy dx. All right, well, it's the first times the derivative of the second. So derivative of cosine is minus sine. And notice I didn't put a gigantic parentheses and try to sneak that minus sign right in here, right? So I'm like, okay, it's sine of x times minus sine of x. Let me just keep track of the minus sign and pull it all the way out to the front of the term so it doesn't look like it's sine of x minus sine of x. It's sine of x times negative sine of x. So it's the product of two things, not the subtraction, not the difference. So I'll keep track of that minus 1 and move the minus 1 outside. So it's sine times the negative sign, and then plus, and this was sine times so this one is just right down here, and then cosine, took the derivative of cosine and it became negative sine, and then plus the second one, cosine of x, so that's the second one, and then times the derivative of the first one. So d by dx. So sine, derivative of sine is cosine, so plus cosine of x, just like that. So we have minus sine of x, plus cosine of x, cosine of x. And then I like to, since I have negative of something plus something, I'm going to rewrite it in the opposite order. It's cosine squared of x minus sine squared of x, just like that. Right? Because negative, when you add a negative, you're subtracting, so it makes sense to write this term second. So I move this term to the right, and then this term over to the left. So if you have y is equal to sine of x, cosine of x, the derivative is cosine squared x minus sine squared x. And that is the product rule.